Bristol Community College, Mathematics with Dan Avedikian, Math 132, Calculus with Applications, Section 15.1, Problem 15. This is Section 15.1. It's problem number 15. We want to take the integral of 6x to the negative 3 plus 5x to the negative 2 plus 3x to the negative 1. So we're going to have our 6 in the numerator of a fraction over the old exponent plus 1, so negative 3 plus 1, x to the old exponent plus 1, negative 3 plus 1. That's the first piece. The second piece, 5x to the negative 2, so we'll have the 5 in the numerator of the fraction, the old exponent negative 2 plus 1 in the denominator of the fraction, x to the old exponent plus 1, so negative 2 plus 1. And then the next one, you're going to have 3 in the numerator over the old exponent, negative 1 plus 1, x to the old exponent, negative 1 plus 1. Now, when I go to simplify this, the first two pieces will simplify nicely. The third piece, we have a problem. That negative 1 plus 1 in the denominator is 0. Can't have a 0 in the denominator. So the first two pieces, the negative exponent is fine. The third piece, that negative exponent is making a big problem for me with the 0 in the denominator. I can't do that. So what's going to happen is it's going to be natural log of absolute value of x. That's how you handle the situation when you get that 0 in the denominator, when you're trying to apply the same format that you do with the other regular exponents. And because of the 3 in front, that 3 will just stay in front. So let me just kind of back up and fill in the other pieces. This 5 over negative 2 plus 1 x to the negative 2 plus 1, that'll be 5 over minus 1 x to the minus 1. Back up a little bit more, the first piece. 6 over negative 3 plus 1 will be 6 over negative 2. X to the negative 3 plus 1 is negative 2. So I can clean all of this up a little bit. So the first piece, 6 over negative 2x to the negative 2. Let me just call that minus 3x to the negative 2. And then the next piece, plus 5 over minus 1x to the minus 1. Well, the 5 over minus 1, let me just make that minus 5x to the negative 1. And then the last piece is 3 natural log absolute value of x. And that's great. And if you stop there, you'll be wrong, because you need to always remember that there could have been a constant, something with no x. So now that's the answer. And again, you can check it if you want. You can take the derivative of what we claim the answer is and see if it takes you back to what the original question was. So the first piece, negative 3x to the minus 2, take the exponent of minus 2, bring it down times the number in front, minus 3. Negative 2 times negative 3, positive 6. X to 1 less power, that minus 2 will drop to a minus 3. The piece in the middle, minus 5x to the minus 1, bring the exponent of minus 1 down times the number in front, minus 5. Negative 1 times negative 5 is plus 5. X to 1 less power, that negative 1 will drop to a negative 2. And the piece on the end, 3 ln absolute value x. Well, the 3 will stay in front. The absolute value of x here, you can just call it natural log x. The derivative is 1 over x, which can be written x to the minus 1. And the constant on the end would just go away when you take the derivative.